Hello students, in the last lecture we have studied pre-emphasis filters and de-emphasis filters in FM system. So these are the review points from previous lecture. The point 1 is the pre-emphasis filters are used to boost 2.1 kHz onward frequencies from information signal to protect them from the channel noise interference. The information frequencies from 2.1 kHz to 30 kHz are boosted in FM broadcasting system. Pre-emphasis is done at transmitter before the modulation. At receiver, boosted frequencies are attenuated to their original level by de-emphasis filter. De-emphasis is done at receiver after the demodulation. The pre-emphasis and de-emphasis are implemented in FM broadcasting system to help to improve the signal to noise ratio at output of the receiver. Today's topic: generation of stereo signal. Stereo signal in FM broadcasting system is generated by combining information signals captured by left channel of microphone and right channel of microphone. In diagram, we can see the left channel microphone as L and right channel microphone as R. The frequency range of captured signal is from 0 to 15 kHz by both the microphones. These information signals are added together as L plus R and L minus R. They have the frequency range from 0 to 15 kHz. L plus R and L minus R passed through pre-emphasizer for boosting of high frequencies. Then we get L plus R dash and L minus R dash. There is a oscillator which generates sinusoid of 19 kHz. The frequency doubler converts that sinusoid into 38 kHz. L minus R dash modulates the carrier of 38 kHz to generate DSB signal. This DSB signal is centered at 38 kHz with maximum frequency of 53 kHz and minimum frequency of 23 kHz. These DSB signals have range from 23 kHz to 53 kHz. Finally, we generate stereo signal S by adding L plus R dash pilot carrier of 19 kHz and DSB signal. So in spectrum of stereo signal S, we have L plus R dash from 0 to 15 kHz. Then at 19 kHz we have the pilot carrier and DSB signal from 23 kHz to 53 kHz. Further, this stereo signal is provided to the FM modulator for modulation purpose, and after the modulation the signal is sent out. The pilot carrier of 19 kHz is used for the demodulation of stereo signal at receiver side. We will see demodulation of stereo signal in FM receiver unit. This is the spectrum of stereo signal as explained earlier. So we can see that from 0 to 15 kHz in the spectrum of stereo signal we have L plus R dash. At 19 kHz we have sinusoid, that is a pilot carrier, and we have DSB signal which is centered at 38 kHz having maximum frequency 53 kHz and minimum frequency 23 kHz. In this way, the stereo signal has the frequency range of 0 to 53 kHz. In frequency modulated signal, the carrier frequency changes with amplitude of information signal. The frequency of unmodulated carrier is, let us say, omega c, As information signal amplitude changes towards positive value, the frequency of the carrier starts to change to value greater than omega c. Similarly, as information signal amplitude changes toward negative value, the frequency of the carrier starts to change to value less than omega c. So, resulted FM signal has variable frequency with respect to the amplitude of information signal. Now, one can achieve frequency modulation with the help of voltage controlled oscillator, that is a VCO. And in VCO, the frequency is controlled by external voltage. The oscillator frequency varies linearly with the control voltage. We can generate an FM wave by using modulating signal m of t as a control signal, which gives us the equation which has been displayed, that is omega it is equal to omega c plus kf m of t, where omega c is the frequency of unmodulated carrier, kf is the constant for frequency modulation, and m of t is the information signal. Now one can build VCO using op-amp. Here we are achieving deviation in the frequency of the carrier directly. Means the deviation changes as there is a change in the amplitude of the information signal, and that change is in proportion with the amplitude of m of t. That is why this is called as direct method of FM generation. Another way of accomplishing the goal of FM generation is to vary one of the reactive parameter of resonance circuit. It may be capacitor or inductor, but we know that practically we can vary the capacitor, so that we can use reverse biased varactor diode in the resonance circuit to generate FM wave. The junction capacitance of varactor diode changes with reverse bias. We can apply information m of t across reverse bias varactor diode to change its junction capacitance linearly with m of t, which will give FM signal across it. This varactor or varicap diode junction capacitance can be varied to limited range, which poses limitation on deviation of FM wave generation. As we know that for commercial FM broadcasting, the wideband FM is used with the deviation of 75 kHz, and this large deviation is achieved with the indirect method of FM generation with the help of multipliers. So in this indirect method of FM generation, first narrowband FM is generated with small value of carrier and small deviation. This narrowband FM is converted into wideband by passing the narrowband FM signal through multipliers and frequency converters. As per our requirement of carrier value and deviation at the output of the transmitter, the multiplying factor has to be decided, and this can be demonstrated with the example. Indirect method of FM generation can be demonstrated with the help of the example. Now in this diagram we have to generate wideband FM. So first narrowband FM is generated with carrier frequency of 200 kHz and deviation of 25 Hz. Now this carrier of 200 kHz has to be converted into 91.2 MHz, and this small deviation of 25 Hz has to be converted into 75 kHz as the requirement of FM transmission system. For this purpose, we require multiplying factor of 3000. But practically, we can have the multiplying value of 64 and 48, which gives us total multiplying factor of 3072. Now this first multiplying value of 64 can be implemented with the help of 6 frequency doubler circuits connected in cascade. The output of this first frequency multiplier is the carrier FC2 is equal to FC1 multiplied by 64. So FC2 is 12.8 megahertz, and the deviation delta F2 is delta F1 multiplied by 64. So we get the deviation delta F2 is equal to 1.6 kilohertz. Now this practical multiplying factor of 3072 gives us deviation of 76.8 kilohertz, that is 25 hertz multiplied by 3072, which can be approximated to 75 kilohertz because it is a close. But this multiplying factor, that is 3072, converts the carrier of 200 kilohertz to the value of 600 megahertz, which is undesirable because we know that for FM we should have the carrier in the range of 88 megahertz to 108 megahertz. Then what is the solution? Solution is to use frequency converter or mixer to down convert the carrier. So here the carrier FC2 of 12.8 megahertz is mixed with the locally generated signal of 10.9 megahertz to get FC3 is equal to 1.9 megahertz, that is 12.8 minus 10.9 megahertz. The deviation remains unchanged, that's why del F3 is 1.6 kilohertz. The next multiplier is of value 48 and it is implemented with the help of 3 frequency doubler circuits and 1 tripler circuit. The output of this multiplier contain carrier of 91.2 megahertz and deviation of 76.8 kilohertz. Finally, after power amplification, the signal is sent out. So here the number of multipliers, frequency converter and mixing frequency can be designed as per the requirement of carrier frequency and deviation at the output of FM transmitter. These are the takeaways from the today's lecture. Stereo signal generator combines information signal captured from left channel microphone, right channel microphone and pilot signal. Direct method of FM generation uses varactor diode. The range of deviation obtained with the direct method is limited. Indirect method of FM generation use multipliers to convert narrowband FM to wideband FM. This method has inherent noise due to the excessive multiplication. Thank you.